Now we'll be looking at this question. A 25 kg body rests on a smooth plane inclined at 60 degrees to the horizontal. What force holds it from sliding down the plane? Okay, so let's take that this is the inclined plane. Now this is the body that rests on the smooth inclined plane. Now, what force holds it from sliding down the plane? Now, the force that holds it from sliding down the plane could be the frictional force. And again, assuming we are applying a force to this object to go up, and let's assume that it refuses to go up and it hanged, it means that the frictional force is greater than the force we are applying to it, because for me to push this load up, for me to push it up, it means I will apply a force that is greater than the frictional force. So the force that will hold this from sliding down the plane when I'm not applying any force is the frictional force, because assuming you keep this on top of this, if there is no force, you find out that it will slip down. But for it not to slip down, it means that there is a force that is holding it there. Okay, and it will call it the frictional force. So let's just make some proofs here. But on normal notes, the formula for frictional force, I can denote it by Fr is equal to mg sine theta. We're going to make a simple proof here. And another thing we have is the normal force. So this horizontal force, we call it the frictional force. Okay, and we have another one that is perpendicular to the load. We call this one the normal force. Okay, this one is the weight of the load. This is mg. Then we can trace the normal force. This is angle of inclination. This angle here is equivalent to this angle here. There is also angle 60 degrees. So we're gonna make some proofs, but the proof is immaterial. But I think it is good you have an idea about that. Okay, so your frictional force, the formula for frictional force is mg sine theta. Then why the normal force Fn is given as mg cos theta. So here is the proof. Here is the simple proof. If this is our inclined plane, watch. This is our inclined plane, and here is the load. So you draw a line that is parallel to this. That is the weight of the load. This represents the weight of the load, mg. Okay, now the line that is parallel to the load, this one is the normal force. Call it Fn. So I can trace it down here. Okay, I can trace it down here. So now here is the angle of inclination. Here is theta. This is a right angle triangle. Here is 90 degrees. So if you check very well, this we are looking at here, this we are looking at here is nothing but a right angle triangle. Okay, what angle do you think that this subtend here? What angle do you think this subtend here? The angle this subtend here will be, here is 90 degrees, here is theta degrees. Then what do you think here will be? So sum of angle in a triangle is 180 degrees. Okay, that's the total sum of the angles. So if I call here angle x, what do you think is angle x? So it means that theta plus 90 plus this will be equal to 180. It means that theta degrees plus 90 degrees plus s degrees is equal to 180 degrees. So it means that s degrees will now be equal to 180 minus theta minus 90. So s degrees is equal to 180 minus 90 is 90 minus theta degrees. So the angle here is 90 minus theta degrees. So the angle here is 90 minus theta in degrees. So now, if you check very well, this line and this line are what? Parallel. This line and this line are parallel. So since this line and this line are parallel, it means that they both subtend the same angle. So if this angle here is 90 minus theta degrees, it means that the angle here is also 90 minus theta degrees. So the angle here is 90 minus theta degrees. So what will be the angle of this place here, this point that is required? What is the angle of this point that is required? So the angle of this point that is required, remember that this now is a straight line, meaning that the angle from here to here is 90 degrees. Okay, so what angle is here? Since here is already 90 minus theta, then what is here? So we have that the angle here the total angle from this point down to this point is 90 degrees, where from here to here only is 90 minus theta, which is this angle we have here. So what is here? So it means that if I call here angle y, let's say when I say 90 minus theta degrees, because from here to is 90 minus theta degrees plus y is equal to 90 degrees. So if I collect like terms here, I have that 90 minus theta degrees plus y is equal to 90 degrees. So our y will be equal to 90 when this goes over minus 90 when this goes over plus theta. So we have that y is equal to 90 minus theta is gone, then we have theta degrees. So it is tell us that the angle here is equivalent to theta degrees, which was exactly what I said earlier, that the angle here is equivalent to the angle here. So there is no need making the proof, okay? This is a long process, but I'm just trying to show us how this thing came about. Just carry the angle here, fix it here. They are equivalent. So now, if you check this very well, this is the horizontal force, which I call the frictional force. I can still bring it down here. This is also a horizontal force. If I take this, this is also a horizontal force. So the angle here is equal to the force here is equivalent to the force here. And again, we have the vertical force, which is the normal force. It is also equivalent to this one that is here. Okay, so if I should bring this thing out, what I have is this. Okay, where this is the weight of the object mg, which is this is the angle is subtend, which is 60 degrees. Now this is the normal force. Okay, this is Fn, while this, the horizontal, which is this, this is parallel to this, so this represents this, while this one is the frictional force Fr. So look at the implication. Like I said that frictional force is mg sin theta while normal force is mg cos theta. So look at the implication. If I have mg, so how do I resolve this? Because this mg weight is also a force. Okay, weight is also a force. So how do I now relate this? How do I resolve it to frictional force and normal force? So I can apply SOHCAHTOA. So if you look at this place now is our hypotenuse, because if you watch this place is our hypotenuse, this place is our opposite, and this place is our adjacent. So if I want to find the frictional force, it means I am to obtain the value of the opposite. If I want to obtain the normal force, I'm to obtain the value of the adjacent. Okay, I can still draw this. Okay, I can still flip this thing around like this, or I can flip it around like this, such a way I'm going to have something of this nature. Here is the 60 degrees. So the downside is Fn. If you check, this is the downside. Here is Fn. Then this part is the frictional force. Here is Fr. So if you check, frictional force is in the opposite segment, while normal force is in the adjacent segment. But making this proof is immaterial. Just go straight to the point and use these two formulas. Okay, so if we apply SOHCAHTOA, I find out that I have here is my mg, which is the weight of the object. So to find my frictional force, check which of the formula has something to do with the hypotenuse and the opposite. Find out that it is sine. So I have that sine theta is equal to opposite over hypotenuse. So what is this is tan theta equal to opposite is what I'm looking for, which is my frictional force, over what is my hypotenuse, which is mg. So frictional force is equal to mg sine theta. So that's how this one came about. If I'm looking for the normal force, I will apply cos. I have that cos theta is equal to adjacent. What is my adjacent? Fn over what? Hypotenuse. What is my hypotenuse? Mg. So Fn will be equal to what? Mg cos theta when you cross multiply. So anytime you're solving this type of thing, you're looking for your frictional force, you're looking for the normal force, just go straight to the point and say frictional force is this, while normal force is this. Okay, so with that being said, now let us find the force that refuse this thing from sliding down, which is the frictional force. So we're looking for the frictional force, Fr. So Fr is equal to mg sine theta. So Fr is equal to, what is m? M is given as 25 kg. Mass is measured in kg, so this is 25 times. What is g? G is the gravitational force, which is 9.8 times. Okay, g is gravity, okay, acceleration due to gravity. Okay, so gravitational acceleration, which is 9.8, then times our theta here is 60, so we have sine 60. So you can use your calculator to get the value of this. So what we have is 2.5 times 9.8 sine 60. So 2.5 times 9.8 sine 60. So this will give us our frictional force to be 21.2176 Newton. So this is FR is equal to 21.21. Okay, we can say 22 Newton. So this is the force that is holding this from sliding. So the frictional force is 21.22 Newton, and it is equivalent to this 21.22 Newton. That's why it refused to slide hand.